St. Peter's?
Sure. I would say the single biggest positive that I can report is that because last year we had a severe boiler problem and our building looked much more like a locomotive with a steam coming out of it constantly. We literally had water turning into steam and going right up the chimney. And I looked at this November's bill compared to last November's bill, and it was half. Last November, we spent well in excess of $2,000 on a gas bill. And it was below 800, it was 800, a little over this year. That getting that boiler repaired saved on both water and big time on gas. Plus, much more comfortable, because even with what we were doing, we still weren't able to get the heat up where we needed to. But so we're happy.
Great, thank you. I think we're missing Detroit Unity Temple today. And also, as Sonia mentioned, Bruce is not joining us. So that means that we're on to Warren.
Okay, I had some good correspondence with Bob, and we're learning about some insulation things, and also we want to just have some expertise to make sure everything's good on the foundation of the church. It is good, it's not a problem, but we just want to keep it that way. So Bob's given us some good references. And then I think the next focus is we want to do that energy analysis with of our building. And I got a note from Kendall, and we're going to set up a day to do that. So that's the next focus. And the other installation things, we've got some other major renovations going on. So we're going to get that done and then focus on the new thing. Okay, that's all.
Thank you so much. I just got a message from Pastor Glass that is his birthday today, so he's going to try to join us by phone, but I don't know if we should tell him just enjoy your birthday. He's celebrating with his wife on the way to a restaurant or something. Anyway, so with that, we'll move, I think, on to Sonia, as Pastor Griffin is not here. So.
Okay. Good morning again. I don't have much to report except that the church is looking forward to a good year, and we're kicking it off, I guess, with a good start. I finally did get the documentation to get all of our contact information and everything to submit to begin getting our utility data directly into Portfolio Manager. So I'll be submitting that hopefully later today, and moving forward from there. That's it. Thank you.
Great. Thank you, everyone.
Okay, great. Yeah, just for some of you who may not know where we left off, we had asked our houses of worship to start an Energy Star Portfolio Manager account, join the DTE hub where we can transfer your data over automatically. And if you're still working on that, Kendall can assist, or your ambassador can assist. And obviously you all know what this means, then you can track your energy and water. Actually, I think waste management's coming, or may already be available too. So we're here to help you guys with that. It will also allow you to share your data with our district. We don't show it to anybody because we aggregate. We have 500 buildings and we have hundreds of buildings sharing with us, and it's just an aggregated data for us to track our reductions within the whole entire district, and you guys are obviously part of that. And this will also help you join the Michigan Battle of the Buildings or the Detroit Energy Challenge, which I'm not positive, but I think we may have a special House of Worship award at some point. So I just wanted to remind you of that. So that's my little snippet there. So we're going to go into presentations now. And our first presenter is Kyle from Catalyst Partners, and he's going to cover the building shell, and we're going to learn a lot. So this is being recorded, and it will be on our YouTube channel from here on out too. So you can always look back or share it with people. So Kyle, would you like to try to share? And I'm going to stop sharing.
Yeah, sure. Okay, can you see my slides?
We can.
Okay, so today there's a lot to cover when it comes to building envelopes, and so I just want to try to get through some of the basics. So that way, when you go through your buildings and if you find any deficiencies that you want to address, you can kind of have an idea of where to maybe start looking to try to fix those items. So again, my name is Kyle Reith. I'm the Building Performance Team Lead at Catalyst Partners, and I hold certifications for systems and building envelope commissioning. So to start things off, just want to look at what an enclosure is actually supposed to do. And it has four primary functions aside from just structural need. And that would be acting as a weather barrier to keep rain and snow and things like that out, to act as an air barrier to prevent air from leaking in or out of the building that's uncontrolled, a vapor barrier to prevent humidity and moisture from entering or leaving the building uncontrolled, and then also a thermal barrier, which we are probably all most familiar with. So to start off with the weather barrier aspect, all building envelopes need to resist the weather. So whether it's snow, rain.
Excuse me, Kyle. I don't know if it's just me, but can you guys see his screen? I did for a minute, but it could just be me. Do you guys see it?
I see a screen of with 8 images on it, and it's not. It
Okay.
hasn't changed since the beginning. So if he's
Okay.
still on the same slide.
I'm sorry. It's probably just me then. Okay. Sorry.
No, I did change slides. Let me try to reshare.
It just said you were still sharing, but I couldn't. There. Now I can see it. Okay. Thank you.
Okay. So this is what I was showing for that last slide. Just kind of the four components of an enclosure. Okay, are you able to see the next slide here with the weather barriers? Okay, so there's different types of weather barriers, and their primary function is to resist any kind of weather elements that are affecting the building, and to just get them out and away from the building so they don't have an opportunity to intrude inside. So you may have siding that would have drainage on the inside. You may have metal panels or cladding, or you may also have a brick system. And all of those are meant to resist a majority of moisture or snow or whatever it may be, and then also have some sort of a drainage system. So with a brick wall, there's weeps, or there's usually a netting to try to capture any materials that get back there and get everything directed out and away. Metal panel systems likewise have they have their rain screen, and then they also have a gap behind them that is intended to direct water out and away from the building. So that's its primary function. It just wants to make sure that the rest of your wall system can manage the other components and not have to deal with the intrusion of water or deal with the effects of driving winds or things like that. The next layer would be your air barrier. Air barrier is exactly what it sounds. It prevents air from moving from the inside of the building out in an uncontrolled way, or from the outside of the building in. And you may notice this as like drafts or an inability to control the temperature in a space or something like that. Those are all signs that you aren't able to prevent air movement within your building. some examples of an air barrier. It could be some sort of sheeting material, which is commonly used, or in older construction, probably a lot of the churches that you guys are in, it may have concrete construction or block. Sometimes those can act as your air barrier as well. This is a precast system, so maybe that includes some sort of sealants, part of that air barrier, or if it's cast in place, just the concrete casting itself would be your air barrier. And the whole point is to prevent infiltration and exfiltration, which you just want to be in control of when air is entering or exiting the building. Anything that's uncontrolled is going to directly impact comfort and your occupants. So there's a couple different things. There's a driving wind that can drive air into or out of your building. There's a stack effect, which is essentially just warm air rises. And when you have a lot of warm air rising and it has a pathway out, then that will draw air in at the lower levels. Again, uncontrolled air that can then cause discomfort. And then there's also combustion and ventilation. Your HVAC systems typically are controlling the ventilation, but you may have combustion, especially if you have maybe some older boilers or water heaters or something that might draw air from the building for combustion. You want to make sure that there's a free-flowing path to make up that air. So that way, again, you're in control of it and not just having to deal with air coming in any opening or crack that it can find. And so if you find yourself with drafts or feeling air intrusion or having issues controlling temperature or humidity, you may want to look at your air barrier. And so this diagram here shows a wall system for a building. In common places would be this bottom plate at the bottom of the wall. If you see air leaking in there, that's something that you can seal up, or it should be installed with gaskets and sealant, but sealant only lasts so long. And so those are areas that maybe you need to reseal them or look for other solutions to prevent intrusion there. Within your wall systems, maybe you have electrical outlets or some sort of other penetration, maybe an exterior spigot that allow for a breakdown of the air barrier. And those are things that you could look at to try to block the air movement in those spaces. Maybe with sealant, or with outlets, they have like some gaskets that you can get, or on the exterior, probably just a weatherproofing or sealant for any penetrations that might have broken down over time. And then at the top of your wall as well, into the attic space, you don't want your air moving up into the attic, because again, that would encourage the stack effect. And so anything at top of wall, making sure it's sealed up, those are all things that you could look at if you suspect that you might be facing some of these issues. Then the next one is the vapor barrier. And these are the two conditions that we commonly see in Michigan. In the summer, you have high temperatures and high humidity. And on the interior, if you have air conditioning, you're looking at lower humidity and lower temperatures. And so there's going to be a desire for air and moisture to migrate inwards towards your interior space, and moisture and vapor as well. And so, there's different ways to combat this. You can positively pressurize your building, which is always a good thing to do, just to have it slightly positive. So that way, and initially, if a door is opened, or if there are imperfections in your envelope, which there always are, the air wants to move outwards, and that would give you more control over comfort. And in cold climates, or in the winter conditions, when it's cold outside and you have your heat on and it's warmer inside, you kind of have the opposite, where temperatures, air and moisture want to migrate out of your building to the exterior. And there are some different scenarios where you may want to look at different building pressure settings, whether it's positive, negative, or neutral. And that would kind of depend on where your vapor barriers are and kind of how your assemblies are put together. Now these do represent, well, the one on the right represents maybe what a common wall type would look like for a current building in Michigan, whereas the one on the left is maybe more indicative of an older construction, basically because of the vapor barrier. A lot of older structures have the ability for vapor to move through the wall system, and they're designed to do that, due to the materials that they utilize and the way it was intended to operate. And so in which case you wouldn't want to just block that. So something to think about. If you have a newer construction, a lot of the newer materials can't withstand that vapor movement as much or aren't designed to. And so we see vapor barriers more commonly today. I think the big takeaway there is that if you have a wall system that doesn't have a vapor barrier and is intended to have vapor move through it, you're probably best sticking with that method and not trying to redesign that wall or re-engineer it, but more so try to get it back to its intended function if there are any deficiencies. This is just a general overview of a vapor barrier. You want to have a continuous barrier throughout the building, and so that means you have a barrier under your concrete slab, you have a barrier within your wall system, and you have your roofing system, and they all need to tie together. If you find that you have humidity issues in your building, or you're having issues with moisture or freezing within the walls at some point within the wall system, these connection points between different barriers are culprits where failures can happen more easily. But in general, your vapor barrier is where you'd want to investigate that. Continuous barriers, so the foundation, you have a sheeting that goes under the foundation. Obviously not much you can do about that after construction. If you have it, great. If your building was built before that was common, then you may not have it, in which case you most likely have a building that's designed to allow vapor movement. Wall systems, it could be a sheet or spray applied. And then on roofing, there's a lot of different roofing types, but like a TPO is a common one we see today. For vapor leakage, just to kind of get it into perspective, if you had a 4x8 sheet of gypsum that had vapor differential from one side to the other, so it wanted to travel through your gypsum board, that board itself may allow 1/3 of a quart of water through over an hour under some of these, this fixed condition. But if you had a hole in the wall, just a 1-inch hole, maybe like a poorly sealed electrical outlet or something in a drywall opening, that could allow up to 30 quarts of water in just by allowing the migration of air and moisture. And so in the summer, if you guys are seeing anything where you have high humidity in the spaces, it's muggy, it feels sticky, and you can't figure out what's going on, your HVAC seems to be working properly, this would be a good place to look. See if you can feel any air movement, where you have any penetrations or openings in your walls, and looking at inside, interior and exterior to see if you can find any potential leakages. The next is the thermal barrier. Thermal energy can transfer through radiation, convection, and conduction. And these kind of highlight those 3 different methods. Radiation would be between surfaces that aren't touching. Convection would be through the movement of some medium like air. And then conduction would be through materials that are touching or just have a temperature gradient across them. And to combat that, you can use insulation, of course, and there's a lot of different types of insulation. And there are applications where some types are more important than others or more applicable than others. So there's batt insulation and blow-in insulation that you can commonly see in walls and in roofs. And blow-in insulation may be a good option if you're looking to ever retrofit or add insulation. That's usually one that's easier to get into an existing structure. And then there's rigid insulation, mineral wool. You have 2 different types of polyiso, with and without the foil face on it, which would basically say if it does or does not allow vapor to travel through it. And then just like your typical styrofoam. And then there's also spray foam, which comes in open cell and closed cell styles. And really, if you want to add insulation, these are kind of the options that are out there, but it's definitely worth having someone look at your construction type and recommend an appropriate insulation type for you. And then thermal leakage is kind of the result of poor insulation. There's a lot of different areas where it can happen. Windows and doors and any kind of openings or penetrations are a great place to start looking. On windows, you can look at sash leaks. You see little streamers like this. Streamers indicate air movement. So if you have air leaking in, something like that, it would show up in that way. And so you might want to look for seals or something like that. The frame, here, this frame is very dark, so that would indicate it may not have a thermal break, maybe it's conducting, or maybe there's a failure of a seal. This outlet, it appears this outlet is leaking, so that would maybe be air moving through the wall system there. And at the floor plate here, you can see the cold gradient. Potentially there's not a good seal at the floor plate or something there that needs to be looked at. Door seals as well are a common culprit. Just making sure that they seal properly can make a big difference, especially in the hot summers and cold winters. And then this is an image, top right is an image of a ceiling that has poor insulation at the edges of the roof. Things like that where you might want to consider additional blow-in insulation or batt insulation. So next I want to go through some signs of compromised building envelopes, things that if you're walking through your building and you see, you may want to take note of and consider taking action on. So any peeling or flaking paint, that can be a sign of swelling, which would be due to moisture, which, in this top right picture, hopefully you don't see that. I think that's pretty obvious. If you have water just dripping out, that's a problem. But a lot of times it's not that obvious. It's just moisture or some condensation that continuously shows up in one area and then can lead to mold or swelling of drywall or plaster or something like that. Likewise, you can see this black in the windowsill, and you can see like the paint degrading. Those are all signs of moisture, things that you could look at and see, and it could cue you in that maybe there's something that could be improved there or something is broken down. Mold is an obvious one that I think everyone is kind of keen on. So anywhere you see mold, that means there's moisture, and your building's not intended to have moisture sitting in any of your interior or wall spaces. So anytime you see mold, just know that there's most likely a cause that needs to be addressed, and then also just the repair of the damage. The next one is drafts. We've kind of gone through a lot of these, but this image I thought indicated a lot of good places to look. So at your ceiling level, if you have a lot of opportunities for air to escape, that's going to encourage air to make up for what's escaping in other areas. So by having infiltration coming in. There's penetrations from air conditioners that would be good places to check for leakage. Where your floor to floor connections are, potentially there could be leakage there if there's not a good seal at the floor plate or at the ceiling level. Where your wall cavities meet your attic, you want to have airflow in your attic, but you want it to go from your eave up into the attic space and be neutral temperature to the outside. So you really don't want your air from the interior of the building going up into your attic space. That can cause melting of snow and icicles and things like that can cause damage or just be dangerous. Any penetrations to the attic space are good to look at. Exhaust fan openings, duct connections, lights, whatever there may be. If you have a lot of infiltration, all of those things could be adding up to maybe what is equivalent to a large opening, but not apparent as a very large opening. And then there's like window seals, door seals, and those types of things as well that are all great to look at. Condensation is another one to look for. If you have single pane windows, you may see condensation, and that's more so a result of an older window technology that it really doesn't have the ability to prevent it. But if you have double pane windows or windows that are thermally broken, you wouldn't typically see that with common interior conditions. Now, if you do have single pane windows or non-thermally broken frames, which means if you touch the frame, it would be conducting from the outside, so it'd be very cold. You can prevent condensation by maintaining a lower indoor humidity, and that would be a good way to try to address the issue related to just the construction of the building, but it may have a negative impact on comfort. But if you do have more modern windows or thermally broken frames and you're seeing condensation, that could be a sign of a break in the seal for the gas between the glass. It could be a break in the seal for the window frame. It could be a construction error that's causing a thermal break of some sort. And those are potential areas for mold to form or for damage to be happen due to the moisture. Also ceiling tiles, if you see them discolored, that's due to moisture. And just know that replacing the ceiling tile isn't the fix. There's usually some cause, and it's definitely worth looking into what that cause is for the moisture. And of course, then replacing the ceiling tiles once it's taken care of. So that was really quick. Just trying to give a high level overview. I'm definitely happy to answer any questions, and a lot of what you come across is going to be specific to your building. So Catalyst Partners is a resource for you to utilize throughout your treasure hunt. So please feel free to reach out if you have questions. We do have a thermal camera, and when we do our visit to the sites that we are sponsoring, we intend to bring it with just because it's a great tool. But if anybody else wants to try to track one down, just know we have one, and we'd be happy to try to share it if there's any benefit to you. All right.
Great.
Well, I wasn't keeping track of time, so I hope it was good.
That's okay. Does anybody have any questions at this time?
Just want to thank you, Mr. Warren Tursky. It's an excellent presentation, very comprehensive overview, and really stimulates our thinking, give us this whole nother organized way of thinking about our building. Appreciate it very much.
My pleasure. Thank you.
Great. Okay, we are going to move on then to Toggled and Rob Schmidt, who's going to talk about lighting.
Okay, can everybody see my screen?
I can, yep.
Yes.
Can you see the screen or no?
Yes, I can see it.
Okay, great. Thank you.
Yeah.
Okay. Yeah, Rob Schmitz. We're with Toggle. I'm here with Ryan Day. I'm on the marketing side. I thought it'd be good to have our Metro Detroit sales lead here as well, so we can interject as necessary. So I think we're just going to jump in. I can go through the agenda, but really we're going to be talking lighting this afternoon. Before I even start, so Toggled's a local manufacturer of LED products. We're right here in Troy. Easy for us to come down, do treasure hunts with you guys if it makes sense. Help in any which way we can. I've got our contact information at the end of this presentation, or you can go through Connie or whatever makes sense. But we're happy to help any which way we can. I think we attended a handful of treasure hunts for lighting last year. They all went really well. We enjoyed going down there, so just definitely involve us as you see fit. But I want to just go through, with lighting, it's definitely an opportunity to save a lot of money and energy. We look at churches, large congregations as great candidates for saving money. You've got very large square footage typically. You're using multi-use rooms, multiple activities going on in the rooms. There are ways, and we'll talk about LED in a little bit, but ways to leverage LED versus fluorescent when it comes to these multi-use rooms. Color temperature comes to mind. When you're eating, something where it's more of a relaxed type of atmosphere, you'll definitely want to use a warm color. Activities and rooms where you're doing games and such, we'd recommend a bright, cool lumen. A lot of people in my experience, when you start to go down lumens and kelvins and color temps, it gets a little confusing. So a lot of people will think of LED as being very cold and uninviting. And I think that's just very inaccurate, to be honest with you. They've come a long way with LED, with efficiency, and it's just a nice way to complement your lighting and save a lot of good money. So definitely consider LED moving forward. Investment periods, I just want to touch really quick on this. We've seen more recently even better than 1 to 2 years from your initial investment for your return, obviously with the reduced energy bills. So some of the smaller projects we've seen, and Ryan's much more versed on this than myself, 6 to 8 months, and you're good to go. You've got that future of decades of lighting. So definitely a good decision if you haven't already looked at upgrading fluorescent to consider it. And I kind of touched on some of this, but your aesthetics greatly improved with LEDs, security because of the better quality light. As a visitor, I'm in lighting, so I'm always looking at buildings when I walk in. I'm looking at the lighting, but I quickly notice when lights are out and whatnot, it just gives a bad appearance for the building. So it is important to make sure all your lights are on and working efficiently. Extending maintenance periods is another big feature for LED. A lot of buildings, maybe you need a lift, you've got to get up to the ceilings, high ceilings, etc. Fluorescent lights tend to go out yearly, to be honest with you. You've probably experienced that if you have fluorescents. With LED, again, you get decades. So definitely worth that investment. Maintenance periods extremely reduced. We've seen inventory needs reduced, obviously. We've done projects in the past where you go to the back room and they've got every light, dozens of replacements just sitting there ready to go. With LED, just a couple, in case something happens to go out, and that's it. So it's very efficient and reduces areas that you may not consider. And when I said when you're going through a building, yeah, it's obvious you'll see a burned out tube, right? It needs to be replaced. But we've noticed a lot of mismatched colors. Like I said before, you're going from a 3000K up to a 6500K. They look very different. 6500's more of a blue tone. Ryan and I were talking earlier today, like we've gone to projects in especially parking lots where you'll see something at 6500K, which is very blue. Almost looks intentional. If you've ever seen lights where they're blue, most people don't want that. So they may give you a cheaper price, but it's definitely not the route to go. So something we can help you guys with if there are any questions. But burned out tubes need replacement, mismatched colors, flickering tubes. I just want to mention really quick because I see this a lot. Just when you enter a room and it's flickering away, it may be your first instinct to just replace the tube and call it a day, right? Or the buzzing. I know you guys have heard that, just an annoying buzz. Most of the times that's not the tube. The issue lies a little deeper in ballasts. And I'm not going to go through ballasts all too much, but it's something to look out for, flickering and buzzing. When that happens, you do need to replace your ballast and your LED tube. In those situations, there is an opportunity to upgrade with direct wire. That just eliminates the ballast entirely. So when you start looking at your ballast cost, we've seen them from $10 to $50. I've seen them even higher. It's an added expense plus your LED. That's why, and we do, provide products in this realm with direct wire, but definitely something to consider. In totality, it'll save you money there. You never have to replace a ballast again, which is a nice feature too. And not to mention, you have to get the correct ballast replacement. And Ryan's done numerous jobs like this. Sometimes it ends up being an issue. So getting rid of that is a definite if you've got buzzing or flickering. I just want to spend a couple minutes. This is Connie from, hopefully this is still accurate. The checklist from last year for lighting specific. And again, we're happy to walk through buildings with anybody of interest and kind of walk through this and help. But this is, the first step is ensuring proper lighting levels. There's a light meter out there. We have this. You don't need to buy this by any means. If you do want to do it on your own, we've seen them on Amazon, 30, 50 bucks. But it's not necessary. It's something we can come. We'll make sure the lighting levels are accurate for you. You don't always want to replace, specific, the same lights, with the same lighting lumen levels. We're always looking to improve with these upgrades, and this is a tool that helps us do that. Typically what we'll do though, if we do come along or you do this on your own, you'll walk the grounds. We'll do everything that we just talked about, look for the lights, see where you're missing lights, etc. I know we're pointing out here worship areas, offices, restrooms. There's a lot of rooms typically with your facilities to look for. Usually back rooms are culprits. A lot of people aren't looking at back rooms. So we see a lot of light outages and issues in back rooms. So keep those in mind. There's a point here about, blocking the parking lot outside for day burners. This really is more when you have lighting controls or sensors. A lot of times those sensors will get covered with dirt and they get blocked and they're just on all day long. So if you do have an issue with lights being on and you've got controls, you want to make sure those sensors are clean. If you don't, and you're seeing lights on, that's probably your switch, and people are just leaving lights on. That's unnecessary energy loss. And we would encourage considering sensors in that situation. They're really not that expensive and could save you considerable amounts of money. And not a lot of headaches. I think these sensors have come a long way over the years. So, and then just moving on. So upgrading your exterior lighting. This is more for your neighbors, if you will. Consider shielded fixtures that directs light where you need it. We've seen this being a big issue in the Metro Detroit area. Lights are just going every which way. It's a nuisance to your neighbor and it's not giving you what you need. So getting a shield for that is a good way to correct that. I mentioned that checking for cleanliness. Again, it's shocking how quickly things get dirty. Dust, bugs, debris. We recommend, everybody does, cleaning, setting some sort of a schedule to make sure that that's not forgotten to improve your quality of light. There's a point here about considering delamping. This is something that would be paired with the meter, the light meter. A lot of rooms, believe it or not, are lit too much. So again, people that set the rooms up may not have really been looking at those levels and just throwing lights up haphazardly. So there's a chance you get the opportunity to take some lights out to get you to levels that are still good with less energy usage. And then I'm not going to dig into this too much, but T12 fluorescents, if you're not familiar, they're like 2.5 inches. They're the big tubes. Because I know sometimes we take for granted what you're looking for, but if you see a large tube glass, more than likely that's a fluorescent. And we definitely would move to the LEDs, which are T5s and T8s, to get that savings. And we've seen anywhere up to 70% savings. Some of the older fluorescents are really inefficient. I made a note here of some of the newer fluorescents. Your lumens, which is light output per watt, roughly 50, and that's on a good day. With your LEDs, you're looking at 131. So again, that's just showing you where the energy savings is. And that's a low number I'm using for the LED example as well. So definitely something to consider if you guys are looking for energy savings. Longer life, there are a ton of ranges here going on for fluorescents. Honestly, I've seen things 6 months blowing out, but with LED, typically you'll get guarantees of 50,000 hours, which again, if you do the math, you're looking at decades of usage. And I know with us and a lot of other companies in the LED market, pretty easy to get that warranty replacement should there ever be a failure, because they're so rare. And I mentioned direct wire earlier, but again, just to eliminate inefficient ballasts, it's something to consider as well. And we're happy to teach you guys how to do that, teach the maintenance teams how to do it. Typical, just so you know, to do a whole fixture, you can get it done in about 5 minutes. I'm a rookie I think I'm at about 6 minutes to do something like that. So some of the better guys, Ryan here, can do it in like probably 2, but it's something definitely worth the effort. Lighting controls, I touched on earlier. We do offer lighting controls. We manufacture lighting controls, building controls. But again, it's something we can help you guys with. If there is interest, direct you to whatever you might need. Any kind of third party out there. So if there are questions on lighting controls, let us know. But we do see, this is the motion sensing. A lot of rooms aren't in use in congregations. You got, one switch that's lighting whatever 50 fixtures, etc. It may be on all day. It might be worth, I would say it is worth putting a sensor in just to show that there's no activity, it'll turn off. Some hesitancy in the past we've seen with customers is, they don't want the lights to go off after 3 minutes, 5 minutes, etc. You can set the systems up to turn off at whatever duration you really want it to. So if you're not comfortable with an immediate turn off, you can program those things for like hours. 30 minutes would be realistic, especially when people are going home at night and forgetting things on often. I definitely recommend the sensors there. Schedule timers. This is a nice feature too with lighting controls because obviously you can set things up. You can probably do 10 different schedules for a day if you really wanted to. The cleaning crew comes in at 6 o'clock and they're there till 8. When the light's on, you can program it however you see fit. When you start the day, etc. Daylight harvesting, if you guys have heard about that, it's becoming more popular now. And that's just a way to what it says, harvest the daylight that your building has to compensate. So your light will basically be programmed that it will stay consistent at whatever light you set, lumen output you set it at. It'll compensate and actually use less energy when it's bright out. And actually the users, the visitors, customers, whatever you want to call it, won't even see any difference with a good system that is implemented, but you are saving the energy. It's kind of silly to use the same light when you've got a full day out there. So it's just something to consider. Right now, there are a lot of good rebates to incent lighting controls. I know DTE, Energy Star, probably more Ryan's forte. But just as a note, there are ways to leverage the systems with rebates. And Ryan's an expert. He's here to help you guys too if there are any questions. Mentioned that already, the rebates. I did list a couple resources out there if you want to do some research on your own, but Energy Star is a good one. I've put in there energystar.gov. There are additionals. Again, this is more Ryan. Are there any other sites that you'd recommend? DTE is a nice one to check out. And they'll just offer more information, more detailed information than I'm relaying here.
Yeah, DTE is a good one. If it's on the DTE site, there's a good chance they're a reputable company. That was one of my big points from a few slides ago for Rob was, LEDs aren't created equal. There is a wide variety of very high quality product all the way down to the cheapest of cheap. And sometimes, it ends up catching you quicker than you think. If you go through all this work to replace and upgrade to LED, you don't want to be back to replacing your lights, 6 months from now. So there is cheaper options and the highest quality out there, but they will be reputable if they're on that DTE site. So,
yeah.
And I've had another piggyback off Rob here. A lot of places of worship in the last 6 months, they've had LEDs in their buildings for say, 2-3 years now. And they're like, all right, Ryan, what's the next thing? What's the next thing? And that's where the lighting controls are becoming that next, 30%, 20%, 40 in some cases. Places of worship seem to have, little spurts of populations, Sunday service, they might have a full house wall to wall. An hour after service, they might only have one room that's being occupied, but yet the lights are on all day, you know. So that has been their next 30 to 40%, or, you know, all right, we all got LEDs, we did all these upgrades, now what's next? And the lighting controls is where the next step seems to be headed.
Yeah, good point. Yeah, it's worth research, honestly, looking at LEDs, for sure. And we can help in that area. I know we offer our own product, but honestly, we're happy to help in that area, even if it's not us.
And I have told all my customers, even people that haven't purchased through us, whenever you're looking into retrofitting, say just a simple 4-foot fluorescent light, 2-foot, 3-foot, 4-foot, whatever it is, go with direct wire. If you're upgrading to an LED, by keeping the ballast, you're just defeating the purpose. So no matter whose product you choose, just make sure you go with the direct wire company. It'll definitely save you in the long run.
With that, I just wanted to give, a quick top line of the areas we can help look for improvements in energy efficiencies. If there are any specific questions, open it up at this point. And then, like I said, we're happy to go out and look at any facilities for sure.
Thank you. Good information.
I got a question,
Great.
and I think, first of all, I appreciate the comprehensiveness of the presentation. And we need to probably make an appointment. I'm going to take you up on your offer.
Yeah.
But I got a sort of a specific question. We've been doing some renovation on our main sanctuary, and we haven't been having services there, and there's been construction work going on. And we got 16 of these antique globe lights, and they originally came, of course, with 300 watt light bulbs. We've subsequently replaced them with LEDs, and I need to buy 4 of them right now. And I've been looking at a SATCO, S-A-T-C-O product, 2700K, 18 watt. And I'd like to and that's equivalent of a 300 watt, but we got 16 of these. And could we get more light, in layman's terms, could I put a 600 watt light bulb in there? Because I only need 18 watts of energy. So before I was limited because of the amount of energy, but is there another product out there that would give me 600 watts, maybe use 600 light? And we like the 2700K, the warm light too.
Mm-hmm.
Yeah, there's absolutely. We have what's called a ultra high output, what is exactly double of our standard output tube. Our standard comes at 16 watts, and then our high output would be 25 watts, but that's exactly double the lumens. So yeah, there is absolutely ways around that.
That's 6,000 lumens for the high output, which is it's bright.
And these are bulbs. These are bulbs you screw in, right?
We can do both. We have 2-foot, 3-foot, 4-foot. Are you talking about your standard, like screw in like a corn cob, they call them?
Yes, and it goes in a globe, and so we've got maybe 12 inches, maybe 14 inches inside the globe. So you can't. But I think these SATCO fixtures are about 10 inches long.
Yep, they make a very wide variety of both lumens per watt and actual wattage. So some companies choose to up the wattage, and other companies use more efficient actual diodes. So you're using the same energy, getting a lot more brightness out of that diode.
Okay, so I guess it
may cost a little more, but usually worth it, to be honest with you.
Oh yeah, I mean, because the cost of putting added fixtures in, and we need more light. We know that.
Mm-hmm.
And especially at night, and Sunday morning service is fine, because as you say, we got the natural light filling the room.
Yeah.
Okay, so I'll reach out to you.
Yeah.
Okay, very
And
good.
for everyone there, that is my personal cell phone. Feel free to call me, text me, email me, whatever works for you. I've worked with different churches throughout the last year or two. Sundays, I'm still available, just not Monday through Friday. Whenever works for you guys, I'll be more than happy to come help you with the walkthrough or anything you need.
For sure.
So Ryan, I'll reach out to you then, right?
Absolutely.
Okay, great.
Yeah. Any other
Hey,
questions? Yeah.
Yeah, I have a question. I'm sorry, I don't know if you can see my hand raised or not. But can you speak a little bit more to the benefits of direct wired versus not using direct wired?
Yeah.
So there's two different types of LED replacements right now for your standard T12, T8 bulbs. You have a ballast bypass, which is where you basically do a little simple wiring and you literally just bypass your ballast. So it's called direct wire. And what that does is basically you have an internal power supply inside of your tube. You don't use an actual like electronic or magnetic ballast anymore, those big square bricks that you see inside of your fixtures. And what that does is it eliminates the problem and maintenance of needing a ballast. And then basically same thing. If currently you think your bulbs are out and you change your bulbs and they don't work, it's because your ballast is out. So now you're fighting back and forth. Just eliminate the problem for the future. And
they do make, to build on Ryan's point, ballast compatible tubes that you can put in LED, and that's why it needs to be compatible with that ballast that you're putting in there. You probably have a 60% chance of it being compatible, to be honest with you.
Yeah.
If that works, great. But you're right, you're not getting rid of the ballast the next time it goes. It's a ticking time bomb, so you might as well take it out while you're at it.
yeah, many of my customers call because they have bought LEDs and they don't currently work. And it is not the LED that they bought that doesn't work. It's
Right.
actually their ballast that they have doesn't work. So now
Okay, so
they're
you-
on round 2 of buying LEDs and they still haven't solved the problem. So if we
So you
delete the
would-
ballast from the get-go,
Yeah,
So you
that's-
don't recommend the InstaFit lighting solutions?
correct.
Okay,
Yeah.
thank you.
Typically a ballast, I mean, you might get lucky and the thing will last decades, right? But typically 3 to 5 years for a ballast is a typical lifetime. To Ryan's point, before I get into lighting, I didn't know what a ballast was, honestly. Like, yeah, it's typically an issue that won't just go away. What the InstaFit, whatever you might be looking at, it probably won't work for you in this cases. Yeah.
And then in a lot of situations too, by leaving the ballast, say it's an old magnetic ballast, those InstaFits will actually act as like an amplifier. And in some cases, say the bulb is rated for 18 watts, it's actually going to be running at about 30 because of the magnetic ballast is going to be acting as like an amplifier.
Yeah.
So sometimes I've actually had customers buy LEDs, the instant fit style, and their electric bill goes up the following month. And it's very hard stomach,
Yeah. Right.
to have to go out and purchase all new LEDs for the second time.
In most ballasts, just so you know, they'll suck up 5 watts just by being there, above and beyond. And nobody includes that on the LED, to Ryan's point, because it's not the tube, it's the ballast, right? So that's typically left off. And another reason we feel direct wire is the route to go in most cases. Yeah, good question.
Great. Thank you, guys. Full of
Okay.
information, all good stuff. I'm sure that you'll be available for anybody for any future questions.
Absolutely. Sorry for going a little long there, Connie.
No, that's okay. We're going to move quickly over to Diane from D2 Solar so we can fit her in today. See you, Diane.
All right, thank you, Connie, and hello, everyone. Hi, my name is Diane Cheklich, and I am with D2 Solar. We are a solar warehouse, wholesale distributor in the city of Detroit. My partner, Diane Van Buren, and I also do a lot of solar advocacy to help Detroit realize its solar potential. I'm glad that I'm going third today because it's real important before you think about going solar to have your building be as efficient as possible, right? You don't want to, you're just going to need more energy to power all these inefficient lights if you haven't upgraded to LED yet, or to power heating systems that are not efficient either. So it's really important to focus on those things first. Then you'll need less solar to power your building. So that was a good order of events. I personally have been involved in some other solar ventures, including one on a house of worship. The First United Methodist Church in Ferndale has solar on it, and I was an investor in that through a third-party financing model, so I can speak from some firsthand experience today. So thanks for having me here, and thank you for hanging in there. And I'll get started with my screen. Can everyone see that?
Yes,
Okay, so let me get in the slideshow mode here. Okay, so solar on houses of worship in 2023 is going to be a little bit different and hopefully easier than ever. And I'm going to get into why that's going to be the case. You all are already here. You already have your motivations, but just as a quick overview, I'm going to touch on those. I'm going to talk about some new incentives coming through from the federal government and the Inflation Reduction Act. And then we'll talk about some different ways that you can finance solar. Solar is great, it saves you money, but you know, it's got to get paid for up front, right? And what are the options to do that? So the motivation is usually multifold. One is to save money on electric bills. Solar is a way to save money, and it's quite a cost-effective investment over time. Second, fulfill your stewardship values of your faith. On the right here, you can see the United Methodist Church tenets of stewardship. And so the solar on the Ferndale United Methodist Church helps that church to fulfill its stewardship values. Fighting climate change is a part of that. And of course, that's looming larger every single day. And then finally, as a leader in your community, you can set an example for members of your congregation, members of your community who might consider going solar as well. And it's a good way to share about that experience and to inspire other people to follow your lead. So let's talk for a minute about the Inflation Reduction Act. I'm assuming most people have heard of that, but that's a big piece of legislation that's come down from the federal government really in the last few months. Not only is it supposed to reduce inflation across the economy, but there are specific measures in there to fight climate change and to make it easier for both residences and commercial and nonprofit facilities to go solar. In the commercial world, you can save up to 50% on the cost of solar, sometimes even higher. And the way that breaks down is there's a 30% baseline tax credit that is available. There is an extra credit for domestic content in your system and an additional credit for low-income communities. And the government is slowly realizing that there are inequities in our communities and want to make solar accessible to all and are providing extra incentives for low-income communities who otherwise might not be able to afford going solar. And then the last bullet there is an even additional percentage for areas called energy communities and low-income benefit projects. The energy community definition honestly hasn't not come out yet, but for those areas that do qualify, it could be anything from a brownfield, which a lot of Detroit is brownfield, to this is a community that used to have a coal-fired plant and that's closing down. So there are those definitions still need to be finalized, and we won't know which communities in Michigan will qualify as an energy community. A low-income benefit project is a project where the majority of the people who consume that solar are below the poverty line. So there are additional, anywhere from 50 to 70% of a project could be credited as a part of this Inflation Reduction Act. So instead of having to come up with 100% of the cash, now you only have to come up with 50 or maybe even less. So this is a little preview of the before and after type of picture. Solar has always been great, but as a house of worship, who is a non-taxable entity, it's like, well, it's a big, what's the big deal? I can't take the tax credit, so how does that benefit me? After the IRA, you you can take, they're realizing that that was a flaw in the previous incentives. And so now nonprofits can take a direct pay instead of a tax credit. So that's 30% is now available to you as a house of worship as a direct payment instead of as a tax credit. So now that opens it up to everyone in the nonprofit world. Before the IRA, there was a maximum of the 30% financial offset. Now, as I just mentioned, that's up to 50% and possibly higher depending on the nature of the community and the project that you're taking on. And before, all credits were to end in 2023. In fact, they were sunsetting, they were starting to go down. Last year was supposed to be 26% and this year 22%. Well, the IRA bumped actually 2022 back up to 30%, and those credits will extend for 10 years at 30%. So we don't have to be freaking out about, oh, how do I get this done this year? I know the decision process sometimes takes a minute in houses of worship, so you can let that follow its process a little bit easier. There's still some urgency behind this, obviously, but we do have a 10-year window of these credits that are available. So, okay, that's all great, but still, how do I finance this, right? Where do I come up with the money? And I'm going to go over two different ways to do it. One is self-funding, and the other is through a third-party investment or a power purchase agreement. Self-funding options, before the IRA, houses of worship needed to find 100% of that money somewhere, right? Whether it was donations, and sometimes if you're holding a capital campaign, then any money that we would put towards solar might take away from another campaign, another capital expense that we need. So there's a little bit of that kind of cannibalistic challenge in the mix there. So capital campaigns or donations or grants, those are always possibilities, or going with a standard loan. After the IRA, the capital raise required is lower, at least 50% lower, again, assuming that you check some of those boxes with domestic content and the nature of your community. But that's a big deal. Now it only costs me 50%. Maybe I can go find that other 50% somewhere, and self-funding is more of a realistic possibility for me now. On the loan front, I know a lot of houses of worship are averse to borrowing money, but there is a new loan fund that's specifically designed for Detroit that has a fixed interest rate, and interest rates are going up these days, in case you didn't know. And that's designed for the Detroit area. It's subsidized by some foundations it's designed to help the city's residential and commercial clean energy projects be able to move forward where they might not be able to otherwise. And I'm going to talk a little bit about that now. This Detroit Loan Fund is sponsored by Michigan Saves, which is, if you're not familiar with Michigan Saves, they're our green bank in Michigan. They're a nonprofit organization themselves, and they're able to offer the interest rates and the kind of programs that they do because a lot of their funding is underwritten by foundations, et cetera. And this Detroit Loan Fund is available for small businesses and nonprofits, and it can be used to fund your solar project, battery storage, which goes along with solar a lot of times, but it's not necessary. EV charging stations, which a lot of places are thinking about now, and also electrification. So if you are moving, let's say, your heating and cooling systems to heat pumps, electric heat pumps, or lighting projects, it could be used for those as well. You can borrow up to $50,000, maximum of 10 years. It's a 7% fixed interest rate, which again is attractive right now. We have a loan in my company and the rate just went up to 10.5%. So actually D2 Solar is going to apply for the Detroit Loan Fund for some projects that we have to do. And there's no penalty for early repayment. So this is something to think about. We're just learning more about this. This loan's available for a finite period of time, I think the next year or so. So think about that. if your house of worship is considering borrowing money. If you really can't go there for whatever reason to own the project yourself, there is a third-party investment option where some investors that are not part of your church or could be part of your church in the congregation, but a separate group of people actually owns the solar. It gets put on your house of worship, and your house of worship just pays for the electricity from that solar. So that's called a power purchase agreement arrangement, or a PPA. It's usually a third-party LLC where they finance the solar. They take advantage of the tax credit. The house of worship benefits by still having zero capital expense. It only pays for that energy, like I said. You could achieve your solar goals, and typically the price on that electricity is lower than DTE, and so you would save money on your electricity. So it checks a lot of those same boxes without requiring the capital investment. You won't save as much money as if you own the solar yourself, but you still would save money, okay? And this little graphic that I show here has the, for the energy that's generated by the solar, it's like you're getting two electric bills now that would together add up to less than what you were paying before. You'd pay one to this LLC for the energy generated by the solar. And for any electricity that's still necessary after that, the solar may not cover, probably won't cover all of your electricity needs. The rest would be supplied by DTE. So that's typically how that arrangement works. Now, there's also kind of a before and after option here as well. If you're interested in using this third-party option, where do those investors come from? Well, a lot of times it's like, well, who do I know? Or is there someone within the congregation, like Bob Chapman, like me, has done a third-party investor approach to get the solar on St. Peter's. But those people need to be recruited. They need to be, who are they? They need to form an LLC. You need to select an installer, keep an eye on the system, make sure it's up and working, and also create invoices every month for those, for that energy. So there's a bit of a lift there, and I speak from my experience as well. It definitely can be done, and there's sort of a cookbook formula that you can follow, but it's a lift, and it's sometimes hard to find those investors on a case-by-case basis. There is a new option that is kind of being formed as we speak, where there's a turnkey PPA that could be available, where the investor is already in place, the LLC is already in place, the installer is in place, although there could be other installers. And it's basically, you would sign up and get all those advantages of participating in a PPA, but you don't have to kind of create it from scratch and go out and recruit people. And that group is called Solar Faithful, and it is a PPA service that is focused on houses of worship. And it's a nonprofit organization itself, and it's designed to make this PPA model more accessible, to kind of lower those barriers of participating in this type of a model without having to reinvent the wheel and create it yourself every single time. So there is a single financing partner who's already there and has agreed to finance, multiple projects. The participants are still guaranteed a lower energy rate than through the utility, and that's typically a 10% discount. The Solar Faithful officers are representatives from Michigan Interfaith Power and Light. In fact, their very own Jennifer Young is one of the officers. Rob Raffson from Chart House Energy, and Steve Mulder from the Climate Witness Project, which is part of the Christian Reformed Church. I and Diane Van Buren are actually on the board of directors for Solar Faithful, and Murray from Genesis in Ann Arbor. So there's a board of directors of another, I think, I'm not even sure the number of people that are on it yet, but we all have the interest in promoting access to solar to houses of worship who are interested in using the power purchase agreement model. It's just another option out there. So I wanted to make you all aware of it since we're really brand new. There are 5 houses of worship that are already under contract for the Solar Faithful model, and there's 150 more that are interested, and we expect more of those to come on board. So this is another option. You can still create your own PPA. None of these options we're talking about today precludes what we used to do before, but it's just more options to help make solar more accessible to everyone in the faith community. And to me, it's exciting because there are these incentives that are coming down that should make it easier. There are these alternatives in terms of financing that are based on the experience that we've all had, kind of being on the early adopters for it, and are trying to make it easier for the next wave of organizations that come through. So thank you all for your time and interest. Are there any questions on my presentation?
Thanks, Diane. Any questions, anybody?
Okay, well, I had my contact information up there. Feel free, and I'll put it in the chat as well. I will, you feel free to follow up with me via email, and we'd be happy to continue the conversation.
Yeah.
Diane, I just want to really congratulate you and Diane and the others at the Solar Faithful that have stuck with this, because you're right. You're now, besides this good news economically, you're giving people a chance to benefit by a whole lot of hard-earned wisdom and not have to start from scratch. So it's just really congratulations. Thank you.
Thank you, Bob. That means a lot coming from someone who's been down that early road as well. And this is a model that's evolved from like one-offs, trying to make this happen for houses of worship, to I worked with the Department of Energy a few years ago on putting together some template types of processes, and this is all on the Michigan IPL website under their resources. But like, here are some resources that could help you do it on your own. To now we're in this next generation of it, which is, here's a service that's based on all this experience that can make it even easier for people going forward. So thank you for that, Bob. And it's been a road, but we're real excited about the possibilities to take this forward for everyone to help realize their values and raise the awareness about solar.
Yeah, it's amazing the amount of work that you guys have done. And yeah, it's all kind of, I feel like it's coming to fruition right now. All of your hard work is starting to pay off. So excellent. Thank you so much. Any other questions? Can't see myself anymore. I'm assuming you guys can hear me. Okay, if you guys can hang on for about 5 more minutes, we're going to wrap things up, but I'm going to go ahead. I just have a couple of announcements. Excellent speakers today. I was just really glad to have you guys on today, and I just feel like, I can't get enough of the things that you guys are talking about. It's just wonderful stuff. So what I wanted to remind you guys of, just before we take off, a couple of things. Don't forget, we do have our House of Worship dashboard. If you want to get onto it, or you have any issues with it, we can help you. I'm going to try to click into it. It might not show up, but I have it open anyway. So 1 second here. All right. So, this dashboard has everything that you guys need for this program. Your team folders, our meeting information, the dates of our meeting. It has all of the treasure hunt map checklists, which you all know by now that you can kind of run through at your own pace, which part of it that you're going to work on. But so just for instance, today we talked about lighting, so you might want to try to cover the lighting with your ambassador. you know, and kind of work on this checklist as you're going. You know, we try to make sure that we have the speakers that correspond to our different checklists. Okay, so these 3 in a row actually just popped up. You have a solar checklist, you have a building envelope checklist on here, and then you have a lighting checklist. So I just wanted to remind everybody about our dashboard. If you have any questions on it, once again, we can help you get into it if you have not. And then lastly, I just wanted to tell you guys a couple things. I put in the chat box a link to register for our kickoff member meeting for free. You guys are volunteers, your houses of worship in our program. We would love to see you there. You can sign up to up to 2 people with this link. If you don't do it right now today, I can send it to you another time. Just email me and ask me for it. So we have several member meetings throughout the year. This is our kickoff member meeting at the Union Carpenters and Millwright Skill Training Center. And I only said that right because I can read it right in front of me. I never get it correct. But it's an awesome building. It's a great program. We're going to talk about workforce development with them. We're going to talk about DTE incentives. And also we're going to learn about from JLL what 2023 real estate outlook is. So it's going to be jam-packed with information. Lunch is included. So we hope you will join us. Free parking. Jennifer, do you have anything else that you want to talk about today?
No, you covered it.
Okay, so if anybody needs this link, let me know. And you know, just a reminder too, the deadline to get into the Detroit Energy Challenge with your data is March 3rd. So if you're interested in participating in that, let Kendall know. We'll get you all set up. So, okay. Well, I thought it was an awesome meeting. Thank you. Thank you to our speakers. It was really good to hear what you guys had to say, and congratulations to our houses of worship who are making some good strides for sure. And our next meeting is, what did we say, February
15th,
February 15th?
day after Valentine's Day.
Okay, we're going to cover water reduction and rain gardens. We're going to have a speaker from the EPA and Tiffany from the National Wildlife Federation. And we may try to cover stormwater management. I'm just not sure about that one yet, but we will see everybody then. So enjoy the rest of the day. I'm looking to see if the sun's still out, but thank you for joining us, and we'll see you all soon. Reach out if you have any questions.
Thank you.
Thank you.
Thanks, everyone.
Thanks, everybody.
Thank you, everyone.
Thank you very much.
Thank you, speakers.